Okay, so now for arithmetic series. So the only difference between an arithmetic series and an arithmetic sequence is the word series. It still has to have all of those things that make it arithmetic. It has to have a common difference. It needs to, that's basically, it has to have a common difference. The difference are these little addition signs here. Because a sequence is just an ordered list of numbers, whereas a series is defined as the indicated sum of the terms in a sequence. So if I had the sequence 6, 9, 12, 15, 18, if I added all those numbers together, so took the sum of all of the terms in that sequence, I would give me that would represent a series. Now there are two types of series. There's one that's finite, like this one. Finite becomes it comes to a fiend, it comes to an end. See, there are 1, 2, 3, 4, 5. There are 5 terms in this finite series, and I can add those all together. I can take in my calculator 6 plus 9 plus 12 plus 15 plus 18, and I should get an answer. Try it real quick. Now that you're back, the sum is 60. So the evaluation of this series is 60. That's what we're wanting to know. Now, what about something like this? Ooh, well, these dots here means that it's infinite. It goes on forever. We do not know when it stops. And so that makes our job a little harder. It's not too crazy, but now basically we'll have to work on like establishing limits of what we're trying to find the sum of. That kind of complicates the matter a little bit, but for now, just be able to distinguish between finite and infinite, or one that goes on forever and one that has a set number of terms in the sequence. What we're going to be focusing on is finding the sum of arithmetic series. So just like before, you have to be able to determine if something is or is not an arithmetic series based on a common difference. But I want to talk about this kid Gauss, the kid that basically showed how this summation thing works with arithmetic sequences and series, and it's pretty fascinating. Let's say I asked you right now, without a calculator, to quickly add up together all the numbers between 1 and 100. So 1 plus 2 plus 3 plus 4, that's not a 4, all the way to 97, 98, 99, 100. I wanted you to add all the numbers between 1 and 100 together. That could take you an extremely long time, especially without a calculator. And so this kid, I can't recall how old he was, but this kid Gauss, who ended up being a big-time mathematician and physicist, but that's besides the point, he was able to spit out the answer to his teacher rather quickly. He said 50-50. And she's like, how did you do that? That's way too quick. Well, being that there has a common difference, see how it's going up by 1 every time? He knew that these had to form perfect pairs of sums. And so I want to show you something here. 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98, you guessed it, 101. 4 plus 97, also 101. So what he decided is, if there are 100 terms in my series here, I know that means there are 50 pairs of 101. Because all of these pairs add up together to be 101, and 50 times 101 is 50-50. Now, that's pretty impressive, but that's exactly what's going on here. And that brings us to this formula right here. The formula for the sum of an arithmetic series. The sum of some number of terms in a series is equal to the number of those terms divided by 2, multiplied by the first term in that series, added to the last term in that series. So if we use this up here, we'll see 101 is 101. There are 100 terms. 100 divided by 2 is 50. 50 times 101 is 50-50. So you need to be able to do this. You need to be able to evaluate different arithmetic series. And so I want to give you another example to do really quickly. It's one that has a little bit harder of a step. So here we've got 7, 14, 21, all the way to 105. I can see that I'm adding 7 every time. So I've got a common difference, which is great. I know the first term. I know the last term. The only thing I don't know, so the sum of this arithmetic series is going to be the number of terms divided by 2 multiplied by the sum of the first and last term. That's not supposed to be a 2, it's supposed to be an n. So the first term is 7, and the last term is 105. The problem is I don't know the number of terms. That's what makes this difficult. So what you need to do is recall your arithmetic sequence formula to solve for n. So the last term is equal to the first term plus, I'm trying to solve for n, times a common difference of 7. Now use your math skills and solve. Subtract 7 from each side. 105 minus 7 is 98, and that equals n minus 1 times 7. A lot of you are going to want to distribute that. That's fine, but you don't have to. I'm going to divide each side by 7 first, and that gives me 14. 14 equals n minus 1. Solve for n. I know there are 15 terms in this series. So 1, 2, 3, 4 of them are shown here, so that means there's 11 missing terms in there somewhere. But that doesn't really matter. We wanted this 15 so that we could plug it in right there. So the sum of this series is 15 divided by 2 times 112, because that's 7 plus 105 is 112. So 15 divided by 2, 7.5 times 112 gives me 840. The sum of 15 terms in this sequence is 840. You need to be able to do that. You need to be able to do it both ways. Just be given basic information like you have 50 terms and you have a common difference of 3 and the first term is 10 and the last term is whatever. Solve for the sum. But oftentimes, more than not, you're going to have something missing. Maybe a missing number of terms. Maybe a missing last term. Heck, maybe even sometimes a missing first term. I don't know, but you need to be able to use your problem-solving skills to figure that out. The very last thing I want to show in regards to arithmetic series is that you might have to do something in what's called sigma or summation notation. And I'm not going to show you how to do it on the calculator in this video. That's a separate video that will be here in a little bit, where it's just how to punch this into a calculator. You need to be able to set it up without a calculator. So I mentioned earlier that we're going to be establishing limits here. Well, we're more often than not going to go from the first term to however many terms there are. So in this past example here, there were 15 terms. So I want to know what the sum is, and that's what this sigma right here means. It's a capital sigma. It means summation. You want to find the sum. And so I want to find the sum between the first and the 15th terms, including them. So 1 plus the second term plus the third term all the way up to the 15th term. Now in here where I said explicit, right there you put the explicit formula found from your arithmetic sequence formula. So I kind of already have that set up over here. Right here, a to the n, let's find a different color here, blue. A to the n equals a sub n equals a sub 1 plus the quantity of n minus 1 times common difference. So we want to leave this n in there because we want to write the explicit formula. So we just got to kind of simplify. So really we just need the first term and the common difference, and that will make our explicit formula. So our first term was 7, and our common difference was 7. If you do that right there, that will work. A lot of times your answer will be more simplified, and so you may see it like this. You can distribute that in there and get 7n minus 7, and when you simplify that, you'll just get 7n. 7n minus 7 plus 7. Yeah, you'll just get 7n. And so now you'll be able to take this and plug this into a calculator. And I'll show you how to do that in a different video. But for this video, you need to know how to set this up, because there are some multiple choice questions that'll be like, which of the following represent this arithmetic series in summation notation? And that's the answer that we'll be looking for. All right, that is it for now. I'll see you later. Goodbye.